Hello, today we're going to talk about types of data. So whenever we are talking about data, there are two ways that we can classify data. The first way is when we talk about categorical data. This is going to describe a specific quality or characteristic of your data. For instance, we can talk about computer operating systems. That is a category. We can have Windows, Mac OS, Linux, or Ubuntu. Another categorical data example is gender, male or female. So categorical data is when you can break your data up into categories. Okay. The next one is quantitative. The one thing that you should realize in the word quantitative is the prefix quant. That should make you think of quantity, which means that you have a number. So quantitative data is going to be data that has numerical values, meaning that your data is going to be numbers. It's going to be a way of counting. So there are two types of quantitative data. You have discrete and then you have continuous. So discrete data can only take on specific values. An example of discrete data is going to be the number of apples that are on a tree. You can have 0, 1, 2, 3, 4, so forth and so on up until the tree can't have any more apples on it. It can't hold anymore. And that is because you cannot have part of an apple. You can only have whole numbers. So that is a specification on the type of numbers that you can take on. Another example of discrete data is the number of players in a game, whether it's football, basketball, tennis. You can only have a certain number of players. Like, for instance, tennis. Whenever you have tennis, if you're playing singles, you can only have two people playing. If you are playing doubles, you can only have four people playing. So the number of players in a game of tennis is either going to take on the value of two or four, specifically. Getting into continuous data. So continuous data is data that can take on any value. I don't care whether it's a whole number, whether it's a decimal, whether it's a fraction. Basically, continuous data comes from whenever you are measuring. So you can be whole numbers or anything in between. Some examples of continuous data is the time that it takes to run a 100-meter race. So if you're trying to figure out how much time it takes for somebody to run a 100-meter race, you can have a whole number, you can have a decimal, because we already know when you run track, they break things down into decimal places to figure out who the winner is and to track your time. Or you could say the distance of each hit in baseball. Distance has no specific value. You just have to measure it. Okay? So let's look at some examples. Classify each variable as categorical, discrete, or continuous. So when we talk about the cumulative GPA of students in a school, when you think about your GPA takes on any value because the decimal places can go out very, very far. That is how they compare the top people in the class, especially when you're talking about valedictorian or salutatorian. It may come down to hundreds or thousands of a decimal place to figure out who is at the top. If their GPAs are very similar to each other, it may go out a whole bunch of decimal places. So that means that this would end up being continuous. B, if it says we're trying to categorize the shoe size of all students in the class. When you think about shoe sizes, you can only have a half number shoe size or a whole number shoe size. For instance, you can wear a 8.5 shoe or a size 13 shoe, but there's no shoe size that's a 7.25. Okay, it can only take on whole and half size values. So that is going to be discrete. The next data is a person's favorite subject. That is going to be like categories. Somebody may say they like math, they like English, they like history, they like art, so on and so forth. So that is what we call categorical. All right, so now let's talk about simple discrete data. So when we're talking about simple discrete data, you first want to talk about organizing it. So the easiest way to organize data is to use a frequency table. This is when you tally up how many times a certain value appears in the data set. Okay, and this is called the frequency. And you can think about it of how frequent does something happen, how often something happens. So when making a frequency table, we also consider the relative frequency. The relative frequency is going to show how often a particular value occurs within a set of numbers. So now let's talk about displaying data. When you display data, most of the time, we display data in the form of bar or pie charts. So when we do classify our discrete data, we have to understand that bar charts, or called column charts or column graphs, is a graph with a horizontal axis representing the all the possible data values, and it's going to have a vertical axis representing the frequency of the data values. The column widths are equal, meaning that they're the same distance wide, and they have gaps between. Since the data is discrete and your data can only be one specific value, the bar should not be touching. So when we talk about a pie chart displays the data as parts of a whole. And you should remember pie charts from middle school because you would normally look at it as percentages. All right. So the circle represents the total frequency of the data, and then the sectors represent the relative frequency of each value. Basically, your relative frequency in percentage form is your sectors. So anytime we have the mode of the data, you have to know that the mode of the data is the most frequently occurring value. So let's talk about the distribution, describing the distribution. A bar graph allows us to easily see the shape of a data set. There are three types of distribution descriptions, or three different types of ways you can describe the shape. Okay, the first way is what we call symmetric, which means that everything is centered around the mode. So you have to understand that the mode is the highest value or the most frequent. So as we can see here, the two bars that represent my mode is here. And I see that my data on the left of the mode looks the same as the data on the right of the mode in terms of shape. Okay, everything is equally balanced around the mode. So now, if we look at the next one, we would end up seeing that we have a graph. The graph in the middle is a graph that is sort of pushed to the left. So when we identify the mode here, we will end up seeing that majority of the data is pushed. Okay, majority of the data is pushed to the right hand side of the mode. So where the mode is, majority of the data is to the right of the mode. This is what we call positively skewed. And we can call it positively skewed, or we can call it skewed right, depending on the teacher or the textbook. All right, let me fix this. All right, the next one that we have is we have the graph on the right. If we look and identify the mode here, it's this bar here. And as you can see, all of the values, majority of the values, not all of them, but majority of them are pushed to the left of the mode. This is what we call negatively skewed, or we call it skewed left. All right. So if you see that majority of your data is on the right side of the mode, that's skewed right. On the left side of the mode, skewed left. Another way you can think about it is if your data, it looks like it's skinny on the right, I say skewed right. Or if it's skinny on the left, I say it's skewed left. So you can think about it like that as well. So anytime you have data values that are much larger or smaller than the rest of the data set, we're going to call this the outliers because they lie outside of everything else, of where everything else is. So if an outlier is an important piece of data, it should be included for analysis. So we should keep it before we analyze what's going on. If an outlier is the result of an error in the data collection process, it should be removed before you complete your analysis. So let's look at example number 2. So here we have the homework marks out of 10 of 25 students are listed below. The first thing I want to do is make a frequency chart. So if I look at the types of marks that I have, I see that students have gotten 5 marks, 6, 7, 8, 9, and 10 marks. So if I tally up how many times I see them, I see that I see 5, 1, 2, 3, 4 times. So I'm going to draw my tally marks. I see 6, 1, 2, 3, 4 times as well. I see 7, 1, 2, 3, 4, 5, 6 times. I see 8, 1, 2, 3, 4 times. I see 9, 1, 2, 3, 4 times. And I see 10, 1, 2, 3 times. So if I find my frequency here, I have that this is 4, 4, 6, 4, 4, 3. And all you have to do is add them all up to get your total. So I have 4 and 4, which is 8. 8 and 6 is 14. 14 and 4 is 18. 18 and 4 is 22. And 22 and 3 is 25. So that's all 25 of my numbers in the data set. So now if we talk about relative frequency, we are trying to figure out how often it occurs. So basically out of 25, how many times is it going to occur? So if I do 4 divided by 25, I see that my relative frequency is 0.16. So I can put 0.16 for all the frequencies that have 4. When I have 6, I do 6 out of 25. My relative frequency is 0.24 or 24%. And then if I do 3 out of 25, I have 12% or 0.12. Normally when we have our relative frequency, we write them as decimals. All right. So if it says for part B, it says, what is the modal mark of the students? That's the student that received, or the mark that most students received. So as you can see here, I see that 7 is the modal mark because that's the most. It received 6 marks. There were 6 students out of 25 who received 6 marks. You can also look at the relative frequency. Remember, I told you, relative frequency is like your percentage. So 24% of the students got that compared to everything else. So I could say that the modal mark is 7. So part C says describe the shape of the distribution. So before I can describe the shape of the distribution, I need to actually make a visual of it. So I'm going to construct a column graph. So I draw my axis. And remember, the vertical axis is the frequency, and the horizontal axis is going to represent my data values. So I'm going to abbreviate and put frequency here. And then I'm going to abbreviate, and I know my data values are going to be the marks that students receive. So I can receive 1, 2, 3, 4, 5, 6 marks, and my frequency goes up to 6. So 1, 2, 3, 4, 5, 6. And excuse me, I'm not saying that you can have 6 marks, but there are 6 categories or 6 types of marks that we saw. So we have 5 marks, 6 marks, 7 marks, 8, 9, and 10. And our frequency is 1, 2, 3, 4, 5, and 6. So all I have to do is draw my bars going up to the certain frequency. So 5 and 6 have 4. 7 has 6. 8 has 4. 9 has 4. And 10 has 3. All right. So a lot of times when we do have our column graphs, we normally color in the bars, but if you don't want to, you don't have to. So here are my bars. So now that we see this, we can actually do the next part, which is to describe the shape of the distribution. So if we describe the shape, we can already identify our mode. So our mode is 7. And if we look, majority of our data is to the right of the mode. So if majority of our data is to the right, then we can consider this as positively skewed. So now it says what percentage of our data, or what percentage of the students earned more than 6 marks. So the number of students that earned more than 6 marks was 6 plus 4, which is 10, because they earned 7, 8, 9, and 10. 6 plus 4 is 10, and 4 plus 3 is 7, and 10 and 7 is 17, so that's 17 out of 25. So if I do 17 divided by 25, and of course multiply by 100, I would end up getting 68%. Those are the amount of students who earned more than 6 marks. Part E says what percentage of students earned at most 7 marks. So at most 7 marks means that they earn 5, 6, or 7 at the most. So if I do that, that's 14 out of 25. So if I do 14 out of 25 times 100, I would end up getting 56%. All right. Last but not least, we want to make a pie chart. So you already know when you have a pie chart, you draw your circle. And we know that this circle is going to represent the marks. So if I draw my marks, I'm looking at my draw my sectors. I'm looking at my relative frequency, which we can express as percents. So the easiest one to do is the 24% because it's close to 25. It's close to a quarter. So it's going to be around this amount. And I can put in there that that is the number of marks, and the number of marks there is going to be 6. Right? Next, I have the 16% for 5, 6, 8, and 9. So 16% it's not going to be it's not going to be half of a quarter, but it's going to be a little bit over half. So it's approximately like right here. And then the same thing here. So here we can put 5. And excuse me, this should actually be a 7 there, excuse me, because that was the mode. And here we should have 6 and 5 here. And then we can have 8. 8 is 16% as well. And then we are going to have 16% with a 9. And remember, this is just an approximation. It's not going to be exact. So don't worry. So here we are going to have 8, 9, and 10. That is how the pie chart will look with the sectors being the percentages, basically. So if you have a question on the types of data or simple discrete data, please let me know. And you all have a great day.